Good morning, friends. Today I am going to teach about synchronous machine introduction. Introduction to synchronous machine. What do you mean by a synchronous machine? A synchronous machine can be divided into two types: synchronous generator and synchronous motor. Okay, so a synchronous generator converts mechanical energy into electrical energy, while a synchronous motor converts electrical energy to mechanical energy. Both are rotating machine. So what are the rotating machines? Induction machine, synchronous machine, DC machine. While the static machine is the transformer. Okay. Now we know what are the characteristics of a synchronous generator. A synchronous generator characteristics. Okay. Speed of synchronous generator, that is speed, is equal to 1 ns is equal to 120 f by p. P is pole of the machine of the generator. F is the frequency. The poles are always fixed or constant. In synchronous generator, the speed as well as frequency always remains constant. If if that is synchronous machine always rotate with synchronous speed, that is ns. Okay. If it rotates with speed other than synchronous speed, then it is not a synchronous machine. We can define a synchronous machine can be used in thermal power plants, then nuclear power plants, hydro power plants. Okay. In synchronous machine, it delivers both real power as well as reactive power. Sorry. It also controls the both P and Q. That is, the active and reactive power can be controlled in a synchronous generator. Okay. Other characteristics of synchronous generator are it can be operated at any power factor, that is lagging power factor, leading power factor, and UPF. Another characteristic is its efficiency is good. Okay. The power factor can also be controlled. Power factor can also be controlled in a synchronous generator. Okay. Now let us draw the schematic of a synchronous generator. Okay. Let me draw for the salient for synchronous generator. Okay. It is the outer part, or we can say it is the stator. This is the rotor. Okay, here field winding is present, which is excited by a DC source. DC current flows and poles are formed. We rotate the rotor with a speed of ns. Okay, in the stator, armature conductors are placed. Armature conductors are placed. Now, when we excite the rotor through a DC source, let me draw here north, south. Okay, when we excite the rotor with a DC source, current will flow through the field winding and flux is generated. Okay, this flux, this this is the armature conductor. Okay, this this flux cuts the armature conductor, and current is produced in the, it may be cross or dot, we'll see afterwards, in the conductor. This current is collected through the terminals of the synchronous generator and is supplied to the load. Okay, so you can say that a synchronous generator works on principle of Faraday's law of electromagnetic induction. We'll see a detailed video on this. So we can say this is a small introduction to synchronous generator. So now question arises, why should the frequency should be constant? Why? So the question. Okay. The frequency should be kept constant because to have the understanding between generators and consumers, that is loads, the standardization of frequency is essential. As all the generators are connected to the grid, that is parallel operation of transformers, so frequency must be kept constant. And for parallel operation, the frequency must be constant. Frequency and voltage must be constant. Okay. What is the problem with high frequency? High frequency problem. Okay, let me write first why it is important. Because for parallel operation, then understand the relation between generator and load. Okay, high frequency problem. Now we'll discuss. We know power is equal to EV by X sine delta, where X is equal to 2 pi F. When F increases, X increases. X increases, power decreases. So power handling capacity. So power handling capacity of transmission line reduces. Another problem is hysteresis loss is directly proportional to F, and eddy current loss is also directly proportional to frequency. So higher frequency, higher eddy current, hysteresis loss, and eddy current loss. There will be also large effect of harmonics. So we'll discuss more videos on synchronous generator in the next videos.